Start, sir.
Good morning, students, and good morning, everyone. So, in the last class, we have discussed or we have defined the polynomials, rational fractions, and we have defined partial fractions, and the rule one, partial fraction of f of x by g of x when g of x contains non-repeated linear factors. So, in today's class, what we are going to discuss, and I'm going to detail you that. So it is 2a, chapter 7, partial fractions, class 2. Okay. So in today's class, we shall discuss the rule 3. So rule 2, 3, and 4. The rule 2, which is partial fraction of f of x by g of x, PF. PF is nothing but partial fraction. I'm going to write in short. So because we are going to use a lot about partial fractions terminology. So partial fractions of f of x by g of x when g of x contains repeated linear factors. And the rule 3 and rule 4 will be similar. We'll see what rule 3 is. Rule 3, partial fraction of f of x by g of x when g of x contains non-repeated irreducible quadratic factors. So the linear, and now we are going to discuss quadratic factors in rule 3. And rule 4, partial fractions of f of x by g of x when g of x contains repeated irreducible quadratic factors. Okay. So in the yesterday's class, we have defined the rule 1. The problems based on rule 1 also we have done. So in today's class, we shall see rule 2, rule 3, and rule 4. So now coming to rule 2, okay. To find partial fraction, I'm writing in short PF, which is partial fractions of f of x by g of x, which is a rational fraction when g of x contains repeated linear factors. we use the following rule. So what is that? That is rule 2. Let f of x by g of x be a proper fraction, to each factor ax plus b whole power n. A is not equal to 0 where n is a positive integer of g of x, there will be partial fractions of the form, tell me, a1 by ax plus b plus a2 by, because it is a repeated linear factor, it will be ax plus b whole square plus so on an by ax plus b whole to the power of n, where a1, a2, so on an are to be determined constants. Okay, so in the partial fractions, basically we find out the values of the constants. So these are the values. If you look at the previous step, these. Okay, look at this one, a1, a2, so on an are the values to be determined. Is that clear? So now, for example, form of the, will write the form of the rational fraction, and then form of the partial fraction. Okay, now let us consider some examples. One, suppose if the form of the partial fraction is px plus q divided by x minus a whole square. So if you look at this one, this is a repeated linear factor. So what are you going to write? What is the form of the partial fraction going to be? A by, according to the rule, a by x minus a plus b by x minus a whole square. So we'll consider one more example. Suppose px square plus qx plus r divided by x minus a whole square into x minus b. Then if you look at this one, this is the repeated linear factor and this is non-repeated linear factor in the denominator. X minus b is the non-repeated and x minus a is the repeated linear factor. How do you write for this one? A by x minus a plus b by x minus a whole square plus c by x minus b. So this is how you're going to write the form of rational fraction and the form of partial fraction. So we shall do a problem based on this rule so that it will be more clear for you practically. Okay. Let us solve. Say yesterday we have done one problem, so we consider this as number 2. So resolve x square minus x plus 1 divided by x plus 1 into x minus 1 whole square into partial fractions. Into partial fractions. Okay, solution. So what was the note we've discussed in the last class? So whenever you're resolving a rational fraction, you need to check whether this is a proper rational fraction or not. Only then you can resolve into partial fractions. So how do you know whether this is a proper or improper? So for proper, the degree of numerator should be less than the degree of denominator. Okay, so this is a proper rational fraction. The given fraction x square minus x plus 1 divided by x plus 1 into x minus 1 whole square is a proper rational fraction. How? Since degree of numerator is less than degree of denominator. If you look at that, the degree of numerator is 2, and if you expand these two, it will be a cubic equation or cubic expression. It will be x cubed. The degree will be 3. So degree of numerator is less than degree of denominator. Then you can say it is a proper rational fraction, and then we can resolve into partial fractions. Okay. Therefore, x square minus x plus 1 divided by, what do we have? X plus 1 into x minus 1 whole square is equals to, this can be written as a by x plus 1 plus b by, so this is a repeated linear factor, b by x minus 1 plus c by x minus 1 whole square. Okay, applying the rule 2 for the repeated and rule 1 for the non-repeated linear factor. So we'll consider this as equation 1 and we'll try to simplify this further. You have to consider LCM for the RHS. LHS remains as it is. So what was the LHS you have? X square minus x plus 1 divided by x plus 1 into x minus 1 whole square is equals to, I'll write the step again so that it will be easy for you to calculate from 1. The step as it is x plus 1 plus b by x minus 1 plus c by x minus 1 whole square. You got it from 1. Okay. And consider the LCM. The LCM is going to be x plus 1 into x minus 1 whole square. So what will be there? A into x minus 1 whole square plus b into x plus 1 into x minus 1 plus c into x plus 1. And what is there on the LHS? X square minus x plus 1 divided by x plus 1 into x minus 1 whole square. So these two terms get cancelled. And what is left? X square minus x plus 1 is equals to a into x minus 1 whole square on the numerator plus b into, what is this? A plus b into a minus b, a square minus b square. You can apply that formula. So it will become x square minus 1, b into x square minus 1 plus c into x plus 1. So we'll write this as equation 2. Okay. So the only factor you have here is the denominator. If you look at this one, you have two factors, x plus 1 and x minus 1. So we'll consider those factors and see what are we going to get. X plus 1 and x minus 1 are the two factors. In order to find out the values of a, b, and c. Now we have to find the values of a, b, and c. We need to determine those values. X plus 1 is equals to 0. What is the value of x? Minus 1. X minus 1 is 0. X is equals to 1. So now, first, we'll substitute x is equals to 1. Put x is equals to minus 1 in equation 2. Put x equal to minus 1 in equation 2. Let us see what are we going to get. Minus 1 whole square minus of minus 1 plus 1 is equals to a into minus 1 whole square plus b into minus 1 whole square minus 1 plus c into minus 1 plus 1. So what does this imply? Minus 1 whole square. This is 1 plus 1 minus of minus 1 is 1 plus 1 is equals to a into minus 2 whole square plus b into 0, 1 minus 1, 0 plus c into 0. So what are we going to get? We'll try to write this one. 1 plus 1 plus 1, we have 3 on LHS, and this is 4a. So what do we have? A is equals to 3. This implies a is equals to 3 by 4. We got the value of a. We got a as 3 by 4. And then we have substituted x is equals to minus 1. Now we'll substitute the value of x is equals to 1 in equation 2 and see what we are going to get. Put x is equals to 1 in equation 2. We'll see what are we going to get. X equal to 1 in equation 2. What is the equation 2 we have? This is the equation 2. Okay. Now 1 square minus 1 plus 1 is equals to a into 1 minus 1 whole square plus b into 1 minus 1, 1 square minus 1 plus c into 1 plus 1. So this implies 1 minus 1 plus 1 is equals to, you can say this is 1 square, okay, a into 0 plus b into 0 plus c into 2. So what does this imply? 1 and minus 1 will get cancelled. 1 is equals to 2c. This implies c is equals to 1 by 2. We got the value of c. We got the value of c. Now look at this one. We got a and we got, if you substitute x equal to 1, we got a. If you substitute x equal to 1, we got c value. Okay. Now there is one more value which is b. Using the factors, you got only a and c. Now in order to find out b, you have to simplify this equation 2 and equate the like terms. You will be getting some equations, then you can solve them and get the value of b. Let us see the procedure. Now consider equation 2. What is the equation 2 you have? X square minus x plus 1 is equals to a into x minus 1 whole square plus b into x square minus 1 plus c into x plus 1. This is what equation 2 is. So we'll try to simplify this one. So this is equals to, on the RHS, what do we have? Or x square. This implies x square minus x plus 1 is equals to a into, you're going to use a minus b whole square, x square plus 1 minus 2x plus b into, we'll write it as it is, we'll try to expand in the next step, plus c into x plus 1. So now this implies x square minus x plus 1 is equals to ax square plus a minus 2ax plus bx square minus b plus cx plus c. So now we'll try to take x square terms and x terms. In order that take x square common, you'll get a plus b and x terms, and then the constant. We'll rearrange this one again. Okay. So this can be written as x square minus x plus 1 can be written as, you're taking x square term common, a plus b into x square. So what is that you have? X square terms, a plus b, a plus b into x square, okay, and then x terms common, minus 2a and c. We get minus 2a and c. So what is that you have? If you take x terms, then it will be plus minus 2a plus c into x plus the constant term is going to be a minus b plus c. Now equating the coefficient of x square, we'll try to equate the coefficient of x square. We need the value of b, isn't it? So we'll try to equate the coefficient of x square. Equating the coefficient of x square, what do we get? A plus b is equals to 1. Coefficient of x square is a plus b. Here the coefficient of x square is 1. Okay, equating the coefficient of x square both the sides. Equating, we get a plus b is equals to 1. We'll try to simplify this. What is the value of a? We got a is equals to 3 by 4. So we'll substitute that. So this implies 3 by 4 plus b is equals to 1. This implies b is equals to 1 minus 3 by 4. So this implies, what is the value of b? 4 minus 3, it is 1. So it will be 1 by 4. We got the value of b. So now substitute the values of a, b and c in equation 1. What do we get? Where is the equation 1? So we have equation 1. So here you have to substitute the values of a, b and c, then we get the solution. Therefore x square minus x plus 1 by x plus 1 into x minus 1 whole square is equals to 3 by 4 by x plus 1 plus 1 by 4 x minus 1 plus 1 by 2 x minus 1 whole square. Okay, this can also be written as 3 by 4 into x plus 1 plus 1 by 4 into x minus 1 plus 1 by 2 into x minus 1 whole square. So this is how we are going to resolve. Now we shall discuss about rule 3 and rule 4 and get on with one problem of that based on that. Now rule 3. Let f of x by g of x be a proper fraction. To each non-repeated irreducible quadratic factor, irreducible quadratic factor ax square plus bx plus c, a is not equal to 0 of g of x, there will be a partial fraction of the form ax plus b divided by ax square plus bx plus c, where a B are real numbers to be determined. To be determined. So you have to remember this form. It will be of the form ax plus b by ax square plus bx plus c. So we'll take an example so it will be easy for you. For example, form of the rational fraction. Form of the rational fraction and form of the partial fraction. So what is this going to be? Suppose if it is px square plus qx plus r divided by x minus a, we will consider a linear, non-repeatable linear and a quadratic, irreducible quadratic, non-repeated, irreducible, x square plus bx plus c. You can take the combination also. So the form will be a by x minus a by x minus a plus bx plus c by x square plus bx plus c. So this is for the non-repeated, irreducible quadratic factors. Now we'll see what rule 4 is. It is quite simple. The only difference is it is repeated. Let f of x by g of x be a proper fraction, to each repeated irreducible quadratic factor of g of x there will be a partial fraction of the form a1x plus b1 by ax square plus bx plus c plus a2x plus b2 by ax square plus bx plus c whole square plus so on plus anx plus bn by ax square plus bx plus c whole power n. So we shall see an example so that it will be easy for you to understand. For example, form of the rational fraction and what is the other thing in the table? Form of the partial fraction. Now if it is px square plus qx plus r, and we'll take a linear, non-repeatable linear, x minus a, can take a combination, x square plus bx plus c whole square. This is a repeated irreducible quadratic factor and the form will be a by x minus a plus bx plus c by x square plus bx plus c, plus, as it is repeatable, we are going to take one more thing, a, b, c and d, dx, other constant, dx plus e by x square plus bx plus c whole square. Is that clear? So we shall resolve one problem, or we shall do problem based on this one, rule 3, so that it will be easy for you to understand. Now, let us consider this as problem 3. Resolve 2x square plus 3x plus 4 by x minus 1 into x square plus 2 into partial fractions. Solution. The given fraction, first of all, you need to check the given fraction is a proper or not. Only then you can proceed for partial fraction. The given fraction (2x square plus 3x plus 4) divided by x minus 1 into x square plus 2 is a proper rational fraction. Why? Since degree of numerator is less than degree of denominator. Therefore, 2x square plus 3x plus 4 divided by x minus 1 into x square plus 2 can be written as a by x minus 1 plus bx plus c, bx plus c by x plus 2, because it is a irreducible quadratic factor, non-repeatable irreducible quadratic factor. So we'll consider this as equation 1. So we'll try to simplify further. So this can be written as 2x square plus 3x plus 4 divided by x minus 1 into x square plus 2. Take the LCM. What is the LCM? X minus 1 into x square plus 2. So it will be a into x square plus 2 plus bx plus c into x minus 1. So these two get cancelled, and what are we left with? 2x square plus 3x plus 4 is equals to a into x square plus 2 plus bx plus c into x minus 1. So we'll consider this as equation 2. So now put x is equals to 1. We have only one factor, that is real. Put x equal to 1 in 2. If you look at the denominator, what do you have? X minus 1 and x square plus 2. So you should not consider x square plus 2 because it is, you don't get real factors. So here you get x is equals to 1. So we are going to consider x is equals to 1 in equation 2. So what are we going to get? So this implies 2 into 1 square plus 3 into 1 plus 4 is equals to a into 1 square plus 2 plus bx plus c into 1 minus 1. So this implies after simplification, get 2 plus 3 plus 4 is equals to a into 3. So this implies 3a is equals to 9. This implies a is equals to 3. We got the value of 3. And we have to determine the values of b and c. Now we are going to consider equation 2. Now consider equation 2. So what is the equation 2 you have? 2x square plus 3x plus 4 is equals to a into x square plus 2 plus bx plus c into x minus 1. We'll try to simplify this further. So this implies 2x square plus 3x plus 4 is equals to ax square plus 2a plus bx square minus bx plus cx minus c. So we'll take x square terms common and x terms common. A plus b into x square, a plus b into x square, and then plus c minus b into x minus b and plus c. And what is the constant term you have? Plus 2a minus c. Now equating the coefficients of x square and constant term. What do we get? A plus b is equals to 2, x square term, and the constant term 2a minus c is equals to 4. Okay, so we have the value of a. What did we get? A as 3. So this implies 3 plus b is equals to 2. This implies b is equals to 2 minus 3. So this implies b is equals to minus 1. And let us simplify this one. 2 into, we got a value as 3 minus c is equals to 4. This implies 6 minus c is equals to 4. This implies minus c is equals to 4 minus 6, which is minus 2. So this implies c is equals to minus 2. So substitute all these values in equation 1. There's the equation 1. So we're going to substitute value of a, b, and c in equation 1. So what are we going to get? Therefore 2x square, therefore 2x square plus 3x plus 4 divided by x minus 1 into x square plus 2 is equals to 3 by x minus 1 plus minus 1 into x plus 2 divided by x square plus 2. You can simply write 2 minus x also. This can be written as 2 minus x. So today's assignment, try to take down this. Today's assignment, resolve the following into partial fractions. First one, 9 by x minus 1 into x plus 2 whole square. Second one more problem, x square plus 5x plus 7 divided by x minus 3 whole square, whole cube. And third one, 3x minus 1 divided by 1 minus x plus x square into x plus 2. And the fourth one, it is x square minus 3 divided by x plus 2 into x square plus 1. Okay. So this is today's assignment. Thank you, one and all. Thank you, madam.
Thank you, sir.